Hello, this is Rich, and today I just want to show you a little bit of Snappy update here, Snappy library and Snappy application update. I'm going to do a tutorial about how to create servers and clients in the Snappy library. Obviously, Snappy is a massive library that I've been working on for the past year, and it's getting closer to release. But I did finish up networking, and I wanted to show you how easy it is to get networking going in your Snappy application. So there's two classes that represent networking. We have the network client and a network server. Now each application can create as many servers as it wants and as many clients as it wants, but I do recommend that each computer or each application only create one client or one server. Although you could create one server and one client and act as both, that is possible. So we're going to take a look at the iNetwork system here, iNetworkSystem.h, and scroll down. Take a look at those classes here. So we have the class network server, okay? And we have a couple of methods here, like writing. This method will actually write a string data to the wire and send it right over to any servers or clients that are listening for a connection. Is using TCP will just simply return whether you're using the CCP protocol versus the UDP. Right now UDP is not supported, but it will be supported soon. Get name will get the name of the server. This is just a friendly name that you use upon creating the server. Get hosting IP will just get the IP address of the server that's hosting. And here we go, we have a couple of events. Now, I do have a nice, very user-friendly event system, and it uses templates very cleverly. In fact, basically what you do is you create an event class, and then you pass in the, for a template parameter, you actually pass in the function signature. So you can assign a callback with anything that has the function signature of return type of void, and it takes a socket info as a parameter. And we'll show you about these events and how they work. But basically, different functions, member class functions, just open global functions, and lambdas are all supported on these events here. All you need to do is create the event class, declare what type of signature all functions that are registering to this event are going to be using, and then the event name. So you can see on the server we have the onConnect, so when something connects to us we can have that callback. When a client disconnects from us, we can have that callback. When data is sent towards us, when we send data to others, when data is received from us, on init, so when the server starts initializing, you'll get that. And then when the server is shut down, you get a callback for that. Now, we'll talk about the socket info under the onDataSent event. So the socket info is about the information about the socket that is receiving the data. So the onDataSent would give you socket information about the network server. Basically, what's the hosting IP, what kind of address family is it using, like IPv version 4, IP version 6, etc. And data would be the actual data that was sent or received from the client or server. Beautiful. And we have a couple of member functions here. We don't really need to worry about those. And down here, for ease of use on using these events, I've typedefed a couple of signatures. So instead of you'll see later on, but when we actually assign or subscribe to those events, we don't have to retype the function signature. We can just use the word onConnect event sig or onDisconnect event sig. It makes code a lot shorter, so just for clarity, ease of use, I've just added these typedefs. You don't have to, but I have. And then we have the client. And it supports the same basic amount of functions. We have writing. So if you want to write or send something to the server, you can. Again, it's a string. Decide whether it's TCP or UDP. Again, UDP clients are not supported either. Not yet, but it will be soon. We have the connect, so clients will be connecting to the server. The servers really don't connect to the clients, they'll accept connection, so clients connect to a server. Here you would type the IP address of the server you want to connect to and the port. Very simple. And it returns true upon if it could connect and false if it couldn't connect. And you can get the name of the friendly name of the client that you give it. You can get the server that it's connected to. If it's connected to a server, it'll give you the server name, the friendly name. You can get the port that you're connected to on the server, and you can get the server's IP address. Again, the events are exactly the same as a server, so everything's exactly the same. We have a couple of member data here, and then we have the network system here, network system interface. Well, and the network system is created. I use lazy initialization, so nothing, no system, and actually in an entire Snappy library, not one system is created beforehand. It's only created the first time you decide to access it. So when you go under and type in g_psnappy, get network system, that will create it if it's not already created. When that happens, it will then call the init function, and then when you shut it down, when the application shuts down, you'll call the shutdown function of it. On update, nothing really happens here. I haven't found a good reason to have the update function, so it doesn't do anything at this point in time. Then we have the create server and create client, delete server, delete client, get server, and get client, and then get socket info. So these network clients and the network servers should never, ever, ever be instantiated by themselves, ever. You need to use the network system to create them. So you use create server, create client, and here's the parameters. So create server, you got the name, okay? This is the friendly name, you can give it anything, okay? Then you have the host port, so the server will say you want to create a server on your local machine, which by default it does. By the way, if you're going to create a server, it does create it at 127.0.0.1. So whenever you create a server, it does create it on your local machine. And then you got to give it the port. You can create it on any port, but make sure it's free. And then you can type in whether you want a TCP communication or UDP. Again, UDP is not supported, so you will get a log message telling you that it's not supported. Create client, same thing, friendly name, and whether you're using TCP. Now, we don't type in a host port here. That's because when we actually, clients can choose to use their function connect, and that's where you pass in the port and the IP. And whenever you delete your servers or clients, do not delete them using the delete key. In fact, you need to use the network system to delete and create and manage your servers. Never delete them by themselves. So we have a get client and get server, and basically you pass in the friendly name and it will give you the server. So if you created a bunch of different clients and you give them different names and you want to get a particular one, then you'll go ahead and you just pass in that name of that client you want, and bam, it'll give it to you. By the way, it's a very, very, very common procedure in the whole Snappy library, is that you actually use systems to create resources, and then you use those systems to manage everything about those resources. Very rarely will you see resources create themselves. It always has a manager. That's the type of style I went for with Snappy. All right, so let's get into it. Now that you know a little bit about the network system, I didn't show you the implementation. I'm not doing that quite yet. But let's go ahead and implement a simple client and simple server. So let's go ahead and do this. We're going to use two Snappy instances. So this was the library here, the Snappy library. And then the Snappy example application is right here. This uses the Snappy library. So I'm going to open up the main.cpp. And this main class, every Snappy application that you create should have a main class that derives from the iMain interface in the Snappy library. That way, it's kind of like a game loop. It's kind of like where everything happens, where the core of your application is. You may think of it as an application class, which we do have here. But the main class is where you should handle all of your application-specific logic. And we're going to go to a function here called onInput. Okay, so we're going to go to the main, and then we're going to go to the onInput event. And this is very simple. Whenever input happens in the system, this main class is registered to receive input, so it will, and then it'll get the input event of whatever happened. Yeah, it's a very, very nice input system I've created here. So what we're going to do is we're going to hotkey. Whenever we press S, we're going to create a server, and whenever we press C, we're going to create a client. Here's what we're going to do. So we're going to create a server, then create a client, but when we create the client, what we're going to do is then, okay, we've created a client, then we're going to send data. I'm going to show you how to send data to the server. Then the server is going to receive that data. It's going to then create a text box control using my Snappy's UI system. And then it's going to set the text of that text box to the text that was received over the wire. Pretty cool. I figured that was a good example to show you. So let's go ahead and do that. We're going to detect some input, and well, how we do that? We go if, okay? We're going to take the event that happened, p event, and we're going to, we already know what type it is, but input type, there's a couple of them. There's mouse or keyboard, okay? They're all enums here. But we're going to take the p event args, okay? And then we're going to check if the e key equals e key, and we're going to check for S. We're going to create a server here. So e key S. So we're going to check if the S key was pressed, and we're also going to check if the button state is released. So when the S key is released, we're going to create the server. Very simple. So we'll create a network server variable here, network server. And we're going to access the always available, no matter what file you're in, the Snappy interface here. So, and then we're going to get the iNetwork system. And the Snappy is a place where you get all the different systems, one-stop shop for everything of all the interfaces in the Snappy library. And then we're going to create a server. Once we've done that, we're going to give it a friendly name. I'm just going to call it test server. I'm going to give it a port. We'll just do 4404. I happen to know that that is open on my system. And we're just going to default it to true, so we don't type that third parameter. There we go. Then we're going to check for success, because it will return null if it wasn't created properly. So we're going to check if p test server. Okay. If it does exist, now here's what's cool. We're going to actually subscribe to an event using my event system. Okay. And I'll show you where that type def comes into play. So we got p test server, and we're going to use on data received. So whenever the server receives data, we want to do something. So on data received event, and then we just simply go plus equal. We're going to subscribe. Very similar to how C# works. In fact, my event system and UI system was actually heavily inspired by WPF, although this is all 100% C++ code. I do not use CLI or any managed language. So, and then we're going to have the event handler equals new event handler. Now, we don't really need a member function or a global function. We're just going to simply use a lambda here just for simplicity's sake. But you can use a member function, and you can use a global function. So we're going to create a new event handler, and this is where we would type, the function prototype here. What kind of handler? Well, since this on data received event needs a return type of void, it needs the first parameter of socket info and the second parameter of string, we could do like this: void socket info, and then string. I mean, that would work, but if you have very many parameters like some of these events do, you're just going to want to use that type def here. So on data received event sig. There we go. Much simpler. Once we've done that, we'll open up, and the first parameter we need to type is the event, which is the function, and then give it a event name. So here's the function. Well, we're going to create a lambda. Lambdas are created like this, and then the parameters, and then the body. So again, we're going to have to type in the void, and whoops, sorry, we're going to type the parameters, socket info, and then we're going to do string data, and I just because I will actually do a global version and a member version instead of a lambda. Maybe you don't know how to do lambdas. It is new to the standard C++. So I'll do both just to show you how to do it. And once we do that, the second parameter we need to type is it's just this friendly name so we can access the event or delete it. And what we'll do here is we'll do on data received handler, and you can give it any name you want, but that's the second parameter. There you go. So this actually doesn't follow scoped. It is a lambda. So even though this if statement will be out of scope, and even if it's not in this input function, the function will get called whenever we receive data. It kind of has like global scope, no matter where you define it. That's how kind of lambdas work here. Just very basic. So there we go. We've now made, when we receive data, when the server receives data, we're going to call this function. Well, what are we going to do? Well, the client should be sending a string of text, and we're going to take that text and we're going to create a text box. So here's what we're going to do. We're going to create a, whoops, get rid of that. The UI control P text box equals G underscore P Snappy get UI system, and we're going to spawn a UI control, and controls can only be spawned. You can create your own controls very easily. I'm very proud of the UI system, and I think you'll like it. We'll do another tutorial about how to create custom controls and all that. It's very simple, very, very powerful, but you have to register your controls. I've already done that, and you use the registered name. So we're going to create a text box, okay, and then the position, we're going to use my vector2i class, and we're going to tell it we want you to be at 100, 100, okay, pixels. And then for the size, we're going to want you to be the text box. Want you to be 200, I don't know, yeah, 200 on the width, and we'll give you 100 on the height. There we go. We have that text box. But I'm going to need to access the text box functions here. So I'll actually make this a CUI text box control. And the spawn UI control does return an IUI control, which is the base class of all controls. So I'll just do a simple cast here so I can access the members. And then we'll take the P text box and we will set the text. And we'll set the text to the data that was passed in. Okay, socket info, data. Okay, beautiful. So when the server received data, we're going to create a text box at 100, 100 with the size 200 by 100. And then we're going to set the text box's text to whatever was passed to us. Beautiful. Now that we've done that, let's go ahead and create the client now. If the P event args.key equals the E key C for client, E key underscore C, and P event args button state equals E button state released, then we're going to create the client. Very simple. Let's go ahead and create a network client. G_p snappy get I network system, and then we're going to create the client. Now it's very simple. It just takes 1 or 2 parameters, and it's just a name. And we're going to call it the test client here. And then we're going to default use TCP. We don't need that second parameter. Then we're going to check, because we do return null. Well, I return null if it's not a valid connection here. So P test client, and if we do exist, we're going to head and connect to the server. So P test client. Okay, and we're going to connect, and we're going to connect to the server. And I happen to know I'm connecting to myself, so we're just going to simply type in 127.0.0.1, and then the port. I do know that we're hosting, well, the other Snap. I'm going to create 2 instances of Snappy. One I'm going to press S on, and the other I'm going to press C on. So one Snappy app is going to represent a client, one Snappy app is going to represent a server. And I do know that the server will have a port of 444. Okay, so we're going to connect. I do return false if we couldn't connect, so we're going to check if we can connect properly. If we did actually connect, we're going to send data. So we're connected now. So we're going to P test client, and then we're going to write. Beautiful. Let's go ahead and write some data. We're going to write, hello, I was created using a different Snappy app. Beautiful. Now we've done that. So all we got to do is compile. Okay, so we'll actually go over this one more time. So we have the input event. First we check the input type. Okay, so if the input type is mouse, we do this. If the input type is keyboard, we do this. Okay, so now we know the input type is a keyboard. Well, if the key equals S, and we're releasing the key, then we're going to create a server. We're going to check if it exists, if it's a good one. And then we're going to assign or subscribe to the onDataReceived event. So whenever the server receives any sort of data from anybody, we're going to call this function here. So we're going to create a text box, and then we're going to set the text of the text box to whatever was sent over to us. And we're going to give it an optional name of onDataReceived handler. That just allows you to access this event later. So let's say you're in a different scope, but you still need to delete, because it is dynamically located, these events, the new keyword here. So you will need to destroy this. Sometimes you will, but it's all, if when you close the program, it is automatically destroyed for you. But if you want to destroy it while your program's running, not have to wait till it's, at the end and then it shuts down, then you would simply, I'll show you, P test server here, and the on data received event, and then you would just do minus equals, and then it's overloaded, so bam, and that would unsubscribe and delete this event handler here. You could also, if you did have a function, okay, if you had a member function or a global function, you could just type in the minus equals and then function name. But since we did do a lambda, and there's really no way to keep track of that, it's difficult, you could use the text parameter to delocate and unsubscribe from this event. Beautiful. So we create the server, blah, blah, blah. Okay, but if the key is C, we're going to create a client, and we're going to check, is the client okay? If it is, then we're going to connect to the server. We're hosting on our own local PC at this point, so 127, and then connecting to port 444, and then if we are connected, if we did succeed, we are connected, then we're going to write some data. And we're going to write, hello, I was created using a different Snappy app. So let's go ahead and compile. Give it a second. Oh, by the way, if you guys don't know, sometimes I get asked about what kind of recording software I'm using. I've actually changed software. This is actually a free recording software. It's actually a live streaming software and a file, to the file. So you can do local or live streaming. It is absolutely free, 100%. And not only that, it records absolutely smooth. Like 60 frames per second, no skips, no hiccups, nothing. It's absolutely beautiful. I do recommend it. It's called Open Broadcast Software. Absolutely amazing. Okay, so Snappy application opened up here. And we're going to have to create another one because we want one client and one server. So here's what we're going to do. We're going to right click on the Snappy application and we're going to tell it to debug, start a new instance. So now we have two. We have this one here. So you have two. Oh, by the way, you can see that this whole entire user interface system, this window here is all using my custom UI system. But again, we're not going to go into that today, but I just want to make that noted that this is my UI system. It's a window class I made, UI control. So what we're going to do is we're going to make sure this window is selected and we'll create the server by pressing S. Beautiful. Server is created. Now, on this one here, make sure it's selected. We're going to press C. We're going to create a client. Remember, when the client is created, it's going to send the server over some data. The server is going to create a control, a text box, okay? And then it's going to set the text of the text box, whatever it received from the client. So let's go ahead and press C on this. Beautiful. Very, very fast. So we now have a text box control that was created on the server here. And it says, hello, I was created using a different Snappy app. And what we'll do here is we'll simply just get rid of the client application. Wonderful. And we'll just maximize this window here. So we have a text box control here. It has a border, has some text, and we can actually go ahead and click wherever we want to and get rid of everything. Beautiful. And that will pretty much wrap up our tutorial. So thank you for watching. I just created another client. Oh man. Let's delete that. Oh, I do want to show you one more thing, by the way. Do want to show you one more thing. Let's go ahead and maximize this. Boop. So here we go. We got some texture nodes. Let's get rid of these. Wonderful. Here's our button. Boop, boop, boop. Button control. You may look, it has some shading. That's because the UI system it is set up to do so. So different controls have different render types, and you can set them with a quick little enum, what kind of render type or render mode that you want. You want the background, foreground, background and foreground, image, gradient, or do you want to use effects? Now I do incorporate the new direct 2D effect, so you can use actual shaders on 2D. So what you're seeing here, it's not 3D. This is actually a 2D, direct 2D API here. And it does have the light. It actually has a simulated 2D light over the control, and that's why you're seeing this gradient. It's actually a specular light. It's happening up here on this part, on this side over here, this side down here, and on that side. It's a simulated light. Now, I do incorporate 3D. I do have 3D. So the Snappy application and the actual SDK, Snappy library, uses DirectX 11, meaning you do need a DirectX 11 card. Okay, you need a DirectX 11 card, but you can go down to feature level 9, 10, or 11. But you do need a DirectX, oh my bad, you need DirectX on your system. You don't need a DirectX 11 card, but you do need a DirectX 11 system. So Windows 7 and above. Vista's not supported, so it's 7 and 8. Windows 7, Windows 8. So yeah, so I want to show you this Direct 2D, and this is actually a simulated light. The render mode of this particular button here is set to the effect render mode, and I render a point light effect on it. Very nice. I just wanted to show you that real quick. Also, I do support 3D, so it's a mixture of 2D and 3D. Snappy has, so I'm not sure. I don't think this will work. Some of the nodes here, I've made some changes and they're not working. But we'll go ahead and add a mesh node. Okay, got a mesh node, and we'll go ahead and add a shader node. The shader node is dynamic, meaning there's a default shader that it's using, a DirectX 11 shader, and it automatically generated these ports here that are actually the names of the HLSL variables here that you could give values, but we're not going to do that. And then we're going to need a material. So take a material node, we're going to do that. No guarantee this is going to work. I have made some changes. So what we're going to do is we're going to take the shader, we're going to create a material out of it. Now we're going to take this material and we're going to go ahead and plug it in here. But now we need a mesh. So let's go ahead and double click to open this up and load up a mesh. And what I do have is on the repository, talk again, Snappy, and we're going to go into the data. We're going to load one of these models here. So I do have a head model, so let's go ahead and load that and give it a second. We are in debug mode, so debugging, running in a debug mode, it does take a little while. And as you can see, we're running a default shader here with that character. And he's right over here. In fact, these controls will display over the character, and he's backwards. But I just wanted to let you know that. And he's in memory, so boop, delete him, delete him, delete him. Well, thank you very much, and I hope you guys enjoyed, and hope you guys learned how to use the new network system inside of Snappy. It's wonderful. I do want to make notice that I do have a serialization system, so you can serialize any class that you create, and also any of the base classes that come default with the C++ library, you know, like ints, floats, doubles, bools, and all that. So everything's serializable in the my serialized system. And I do support text mode, serializing to text, binary, and XML, very simply. So you can actually send over, this demo here shows you text, but what you do is you could, if you want to send entire objects over the wire, is simply serialize the object. Okay. Let's say if you wanted to send an entire client over, we would never why we would want to do that, but you could. So first, what we would do is we would take a basic example here, pseudocode. So we're going to take we're going to make an instance of the serializer, and we're going to go serializer, and the parameters here is the type. So we're going to take the serialization archive. We're going to give it a type of, we're going over the network, so we would go ahead and type in a network here, and then your serialization class will decide if it does anything different based on if it's network file or whatever. So you can provide optimizations on the network type if you wanted to in your class. It's implementation specific, specific. And then we want the serialization archive format. In the format, we have binary, text, and XML. So over the net, you probably want to serialize it to binary. You could do text, but binary is super fast and super small. So you can serialize it to binary, a bunch of binary digits here. And then you would give it a file name. We're doing the network, so this parameter won't affect it at all, but you do need to provide it, so you can actually go ahead and write that. You would then take the serializer, and then you would actually write. So what this will do is it will serialize your object. So we're going to serialize the ptest client. Then we're going to get it a name. We're going to call it test client. And if you were serializing in XML, this would be like the tag name. Okay. And there we go. And once you've done that, you would get a handle back to the converted serialized file, and then you could go ahead and write that to the thing. And then when you receive it on the other end, you can go ahead and create a serializer, any serial, you can just recreate one, and then read, and then go ahead and pass the address of a client object. And there you go. It would read it back in. So that's the way you can pass things over the entire objects over the wire using serializing first. Thank you very much. I hope you enjoyed, and see you in the next tutorial. Most likely it will be about the UI system and how to create a custom UI control. All right. Thank you very much. Bye.